Okay, so this is our last part on operator overloading. We'll be doing some more examples. Rather, the examples would be same, but the way we'll be doing them, that would slightly change, right? And just to give you some more idea that all the operators that we have overloaded so far, right? We actually have been overloading operators using member function, right? Means that the function we make is always inside the class, right? And there is something which we repeatedly discussed, right? That if you are using or overloading a unary operator, there are no arguments, right? You don't need to pass any argument. And if you are using or overloading a binary operator, then you pass one argument, right? And we discussed in detail what is the reason for this. The reason was that when you were writing, say plus plus p, so the data of p is already available in the class. You don't need to pass anything as an argument, right? That's why there is zero argument, no arguments. And when we were writing p1 plus p2, so the data of first object is already available in the class, and you need to pass only one argument, which is on the right side. Okay, so this was you can say applicable to the functions which were member functions. Okay, now in today's discussion we'll be doing the same examples, but this time instead of implementing operator overloading with a member function which we have already seen, today's discussion will be focused on non-member function, right? What is a non-member function? It is like a global standalone function which is not a part of any class, right? Just like the functions you used to make in your first course on programming, where all the functions were global or standalone function, right? They were not a member of any class or something similar, right? So today we'll be doing those examples, okay? And what is it that will change? Basically, there will be two key changes, right? First one is that you see when you are using non-member function for operator overloading, the first thing that will change is the number of arguments, right? And the number of arguments in this case will be same as number of operands, right? So what does it mean? If it's a unary operator, the number of arguments will be one, okay? And if it's a binary operator, the number of arguments will be two. Why is it like that? When I write the program, then you will understand why we are saying it, right? Previously with member function, this was 0, this was 1, right? But here with non-member function, the number of arguments will be same as the number of operands. For binary, you will have two arguments. For unary, you will have one argument. The second important thing is that since this function will be a global function, it is not in any class. So when we are outside the class, we cannot write something like p.x or p.y because the data is private. So this would not be allowed. So it means what we'll need to do, we'll need to call get and set methods, right? Because whenever we are outside the class, we know that we are not allowed to access the private data members using the dot operator. Okay, so let's discuss this in detail. So what we'll do is we'll basically overload the same operator, and we'll do exactly the same example, but maybe on the left side we do with a member function. Okay, and on the right side we do with a non-member function. Okay, and I think we'll do the simplest case, which is overloading the plus operator for the point class. Okay, so the point class is already there, and within that class we are trying to overload the plus operator. You have data, you have everything, right? So I'm not repeating it. We do it almost in every class. Okay, so basically when we did it, it was like when we add 2 points, the output is a point, right? The name of the function is operator plus, right? And it needs one input. So we call it say point p. And what did we do inside this function? We said you have a point which is your result, right? And you say result dot x is x plus p dot x. And similarly, you say result dot y is y plus p dot y. And then you write return result. Okay, I'll write the main shortly, right? But first, let me come to this side. Okay, now we are saying this function is actually inside the class. Okay, so when in the main we were writing p3 is p1 plus p2, right? So what was happening, that this second argument was going as an input, and when you are writing x and y, they are x and y of the you can say object which is on the left side, right? So these x and y, they actually belong to p1. Okay, this we have done plenty of times, so I hope it should be clear. Now we are trying to do the same thing with a non-member function. Now this function is not in a class. Okay, so okay, return type is fine. We know that when we add 2 points, the answer is a point. What is name of the function? The name of the function is operator plus. Okay, now you see in the main, when I will write p3 is p1 plus p2. Now this function is not a member of any class. This is just a global function, just like you call a function, say add, and you have to pass it to integers. So you write add x and y, and it gives you a result which you store in another variable. So now this is a function of that sort. Because it is not inside any class, so it does not have access to data of any of the objects. So in other words, what we have to do, if it's a non-member function, I have to pass the first argument as well as the second argument. Means whatever is on the left side and the right side, both the operand, I need to pass as two arguments, right? This is the reason we said that when you are doing operator overloading with a non-member function, the number of arguments is same as the number of operands, right? So there are two operands, you need to pass both of them, because this function is outside the class, it does not have access to anything, right? So what I'll do here, I'll write point A, you can call it anything, right? I'm just calling them A and B, and point B. Okay, so let me just clean things a little so that we can discuss. Yeah. Okay, now you see when we call this function, what happens, this p1 is actually copied in A, right? This goes to A, and this p2 goes to B. So whatever is the on the left side, it will come in the first argument. Whatever is on the right side, it will be copied in the second argument. Okay, now I need to add x components together, right? So first we'll say, okay, maybe I take a point which is my result. Okay, and you see previously we could be tempted to write something like this. Okay, but we cannot do it. Why? The reason is that when we are doing here p dot x, p dot y on the left side, we are in the class, and from within the class we can access private data using dot operator. But here this function is not in the class, so outside the class we cannot access private using dot operator. So what do we need to do? We need to call the get function, which is returning these values, right? As we always make get functions in a class. So rather than using a dot x, I will have to write a dot get x, right? Means you have a function get x in the point class in which you have written return x. Similarly here you will write b dot get x. Okay, so now you have x coordinates of both, and maybe for the time being I can store it in temp x. Similarly, you will add the y coordinates, so you will write a dot get y plus b dot get y, and you can store it in maybe another integer which we are calling temp y. Okay, now you have the addition of x coordinates in the variable temp x, addition of y coordinates in the variable temp y. Now you need to set this result. Again, I cannot write result dot x, right? Previously we were doing result dot x, but now we cannot do it because we are outside the class and x is a private data member. So what we need to do, maybe you can either use constructor or you can call the set function. Okay, so you can say set x, which is temp x, and set y, where you write temp y. Okay, so now you see these statements are similar to these statements on the left side, but on the left side we were directly using dot operator to copy the value. here we are using the set function because we are not allowed to directly access the value. And finally, you will write return result. Okay, so you can, I'll just clean it a bit so that you can compare the left side and the right side. Okay, so let me just remove some extra annotations and then we discuss it further. Okay, yeah. Okay, so what happens when you write this statement? The function is called, right? This is your first object, this is the second object. You are adding x components together, y components together, but the only difference is that rather than writing a dot x, b dot x, you have to write a dot get x, b dot get x, and same goes for y. Similarly, when you have the answer, you cannot directly write result dot x is equal to result dot y gets the value because they are private. So we are calling the set function. And once we have the value, you return something, and whatever you return, it comes to this, you can say P3. Okay. So let me just add this function in a point class. Okay. So that you can see the output, and maybe we can discuss there so that some of your queries will be addressed. Okay. So let me try and share with you our program. Okay, so this is the class we have already made. So now instead of overloading this with the member function, let me just remove it from here, and let me try to add a global function which is outside the class, and we'll be doing it there. Okay, so let me also remove this counter class. Okay, let it be there because there's something I wanted to tell you about it. So this is our point class. Okay, so this is a point class. Now I will be making a function which is not in the class, right? Which is a global function. So let's make it here. I write point operator plus point A, point B. Okay. So now you see we have two inputs to this function. So I say, okay, let me say int temp x is A dot. Now you see I cannot write A dot x. Why? Because it is private. If you write, so it will give you error. Okay, you see it is giving us error because x is private, so we cannot write a dot x, b dot x. So what we'll do, we'll write a dot get x plus b dot get x. Similarly, you will write int temp y is a dot get y plus b dot get y. Sorry. So now you have added the x components together, y components together. Now we can write point result. You can set the values using constructor as well. Okay, so I'm setting the value using constructor. You can use the set function as well, and then you can write return result. Okay, so it is exactly the same logic. The only difference is that we have two arguments and we are calling the get function and or maybe the set function if required. Okay, and now in the main, maybe I can just copy this main close to the point class so that you can actually see both together. Yeah, so now this is the main, and in the main now I can write point p1 which is 2 3, point p2 which is 4 5. Okay, and then I can write point p3, and p3 is p1 plus p2. Okay, and then you can write p3 dot. Okay, so let me give you a walkthrough of this. So we have 2 points p1 and p2. P2 is going in this A, P2 is copied in this B. You add X components together, Y components together, right? So you have those in temporary variable, and eventually you have this result in which you copy the output or the addition of the X and Y components, and when you return, so the return value goes to P3. So you can actually display these values, print them, and convince yourself that this actually works, right? Okay, so maybe now we can take a pause and do some discussion if required. Okay, now basically let's discuss why we need operator overloading using non-member function, right? Member function was doing our job. Okay, so you might say why there's a redundant choice, or why do we have the option of overloading an operator using non-member function, right? There are many justifications for that, but with the knowledge we have so far, I'll give you an example, and I'll develop a scenario where operator overloading with member function will fail, right? It will not work. Okay. In order to understand that scenario, now again, see, we take an example. Okay, the same point class. Say I have a point 2, 4. Okay, this is point P1. In all the examples we have done so far, what we are doing, we are adding 2 points. Okay, or we are subtracting them, or we are adding 2 complex numbers or vectors or anything. So in other words, what we have been doing so far, if I'm adding 2 things, both the things have been of the same data type, right? In all the examples, point is added to point, complex number is added to complex number, and so on. But you see, you might have asked that it is also possible that I add an integer and a point, right? Maybe this should be allowed, just like we can add different data types. So why not add an integer and a point? For example, when I add 2 to a point, so I expect 2 is added to both x and y, and I get a new point which is p2, and now which should be 4, 6. Okay, so this is the new point which I should get. So now you see, it is a slightly, it is the same logic, but a slightly different scenario, where one of the data types is an object and the other is a different data type. And in this example, that data type is actually a basic data type, which is an integer. Okay, so let's first do it with member function, and then we see how this can fail, and then we'll see how non-member functions will rescue us. Okay, so this is the whole sequence of discussion that we'll have in the next 10 minutes. Okay, so let me quickly first do it with the member function. Okay, so just for reference, I am writing what will be what is our objective. So our objective is, we have a point p1 which is say 2, 4, and we'll be adding an integer to it. This is point p2, and we want that p2 is p1 plus 2, or any integer, right? It can be an integer. This is what we want to do. Okay, so first I'll be doing it with member function. So class point. Okay, you can write the data and everything. I'll just be writing the function. Okay, so when you add 2 to a point, the answer is also a point, right? In which you have added 2 in the x coordinate and y coordinate. So we say, okay, return type is simple, it must be point. Name of the function is operator plus. Okay, now it is a member function. How many arguments? One argument. And what do you pass as an argument? You pass as an argument whatever is on the right side. Okay, because the function is called for p1, and what is on the right side, we pass it. Previously on the right side there was a point, so the argument or input to this function used to be a point, but now it is an integer, right? So you see, this is something that we have not done previously. Now we are adding an integer in a point. Okay, so since this can be any number, 2, 3, 4, so that's why I have written int a, or any variable that you like. Rest of the thing is quite simple. I will write point result. So I will say result dot x. Okay, now what is it? X plus a. Okay, I'll explain it with an example as well. Result dot y is y plus a. Now these x and y, they are of p1. Okay, and then you will write return result. Okay, so you see, what did we do? We say this was our p1, which is 2, 4. Okay, this is x, this is y. This is our p2, which is 0, 0. Okay, when we call this function, the value 2 is actually passed as an argument, so this 2 actually goes into this a. And when you are writing x and y, they are x and y of p1, because p1 is on the left side. Okay, so you are writing x plus a, it means 2 plus 2, so this will become 4. 4 plus 2, this will become 6. Okay, and basically you are copying them in result. So I should not update these, rather I should update result. Okay, because this is a different variable, so these stay the same. Actually this result is updated. Okay, they stay 2 and 4. And then you say return result. So this 4 and 6, this actually goes to p2. Okay, so this is how we are adding an integer in a point, right? Which is a different example from what we have done previously. Similarly, you can actually do subtraction or multiplication or division or anything where the second argument is actually something else, not a point. Okay. Now this is okay. This is fine. It's working, but there can be a situation in which this will fail. Okay. Now how this will fail? Let's see. You see, when you are dealing with basic data types, you write x and y integer, you write z is x plus y. It works. And sometimes some other person can also write y plus x. This also works. Okay. So now suppose here someone, instead of writing p2 p plus p1 plus 2, what if someone writes like this? P2 is 2 plus p1. Okay. Because you see, we cannot force the user can write p1 plus 2, or user can write 2 plus p1. It is perfectly okay. We cannot restrict the user for that. But now what will happen? You see, when we were writing this, we know that function is called for the object which is on the left side. Okay, so function is called for p1, and p1 in an object of point class. So it will search for the function in the point class, it will find this function and it will execute it. Okay, but now if someone has written like this, now there is a problem. On the left side there is no object, there is an integer, right? So there is actually no class. This is a basic data type. Integer is not a class. So where it will find the function, because this is not even a class. Okay, so you see, if you write like this will give you an error. Why? Because on the left side it was expecting a class, object of a class, so that it can go to that class and call the function. But now and the second argument p1 should be passed as an argument. But in this case, on the left side of plus we have 2, which is an integer. It is not a class. So that's why if someone writes this one, it is okay. But if someone writes 2 plus p1, then this will not compile. Okay, so this could cause an error. So we actually don't want this. We want that user should be able to write p1 plus 2 or 2 plus p1. Both should work. Okay, why we are restricting the you can say user, and in that case we can only achieve this if we are doing operator overloading using a non-member function. Now what we'll do, since in non-member function there is no requirement that on the left side there must be an object, on the left side there can be anything. Okay, so if we do operator overloading using a non-member function, then this can be allowed. And how this can be allowed, let me just write. Okay, now whatever I am writing, it is now outside the class. Okay, it is not a member function. So I'll write point operator, and the first argument is integer and the second argument is now a point. Okay, so when someone will write 2 plus p1, what will happen? This 2 will go to a and this p1 will go to b. Okay, with non-member function you have no limitation that the first argument or the first operand must be an object. And within the body we can do something similar, right? So I can write, say, int temp x is p dot get x plus a. Why get x? Because this is a non-member function, right? We cannot directly write x with dot operator. Temp y is p dot get y plus a. Okay, and then you have point result dot set maybe both the values, and then you write return result. Okay, now if someone will write this, what will happen? This function will be called. And if someone writes like this, then this function will be called, right? And if you don't want to implement this one with member function, you can even make the same function non-member just by reversing the order of point and integer. Okay, if you don't want a member function, you want everything to be non-member function, then that is also possible. Let me just write the prototype and rest you can complete. So you see, it is perfectly legal that in the same program, you also have a function point operator point p int a, and in this you can write the same body which was here. Okay, exactly the same body which is here. And maybe you say, okay, I will not use this member function, you can delete it. Okay, so now both of these are non-member function. If someone is writing the first one where we have object on the left and integer on the right, then this function will be called. Let me rather change this so that you can view it clearly. Yeah, so now you have a choice. If someone is writing p1 plus 2, then this function is called. And if someone is writing this statement where on the left side you have an integer, then this version is called, right? So this is like overloading, that you have different order of arguments. Int and point, it is a different order. Point and int, it is a different order, right? So it is like function overloading. Okay, sorry, I missed this plus here. We have the plus symbol here. Okay, so in summary, the reason of having operator overloading with non-member function is that sometimes we can have we do not have objects of same class in an operation. And for that, I have given you an example where when we are adding two things, one of those is an object of point class, but other is an integer. Okay, so as long as someone is writing point plus integer, that is okay, your member function will work. But if someone reverses the order, means integer then point, then on the left side we always expect an object if we are doing function over operator overloading with member function. To avoid this scenario, what we do, we can, if we use non-member function, then this problem will not arise. Now user can write point first, integer later, or vice versa, and both of these will work. Okay, let me quickly make this program on the compiler so that you are convinced, and then maybe we can discuss. Okay, so let's do it within non-member function. So we have point operator plus, right? So int a and point say p. Okay, so in this case, it means we are, if someone is writing integer first, so this should work. Okay, so I'll just quickly write say point result and integer temp x is p dot get x plus a. You add a to the x component, you add similarly a to the y component, and then you can write result dot set x and set y and return result. Okay, so now what will happen, that suppose in the main, instead of writing p1 plus p2, I write 2 plus p1. Okay, when you write 2 plus p1, what will happen, this 2 will be copied in the first argument, right? Let me just remove this one so that you can see. So the 2 will be copied in this a, and p1 is copied in p, and you can actually do it. Okay, now let's see what happens if I reverse the order, p1 plus 2. Okay, now you see it is giving error. Why it is giving error? Because in my program I did not make a function in which first I have point and then I have integer. So what we can do, we can simply copy this. Okay, I'll copy this. I will simply make another function and I will reverse the order. Means first I will have point p and then I have int a. The body of the function remains the same, right? Because it is the same logic. Okay, so you can actually see now it is not giving me error. Now I can perfectly do this. It is fine. I have two versions of this operator. I can write p1 plus 2, or I can also write 2 plus p1. So because I have both the versions available, so both of these are now legal statement. There is no problem with that, right? So this is why, this is one reason or one justification of using non-member function, right? So for operator overloading, what were three different ways? One was member function. The second was non-member function. Okay, there is a third way, okay, which is also non-member function. Means it is non-member function, but it is a special function and it is called a friend function. Now, we have not seen friend function is a full-fledged topic that you will see in the next week, right? But to link it with operator overloading, I'll just do one example so that you can understand, because this friend function is mostly used with operator overloading. Okay, mostly. Of course, it can be used in other places as well, but it is commonly used with operator overloading. Now, what is a friend function? In simplest word, it is non-member function, means it is not a part of class, but it has some special privilege. And what is that special privilege? It can access private data. So you see, this is something we never allow, right? But friend function is a special type of function which is not a member of a class, but what you do, you say this is a friend of class. Okay, so this is our class and this is some function here, f. This class has some data which is private and some functions, say a, b. Previously, we have been saying that private data can only be accessed from within the class, right? Means outside the class, no one can access this data. This was not allowed. No function or even main, from the main, if you try to access this private data, this is not allowed, right? You cannot write a.x or p.x. But in some special cases, if we want to allow a function to access the private data, this maybe this f, we say this function is a friend of this class. How to tell it? I'll show you later, right? And if you tell your program that function f is a friend of class point, then this function will be allowed to access the private data of this class. Okay, this is just, you can say, a small note. And how do we do that and why we do that? Let's quickly do an example. Okay, so previously you had this point class, and suppose you are doing operator overloading with member function. Right here you have some data. uh, I'll just write the data, nothing else, x and y. Okay, and in public you have some functions. Okay, and you are doing operator overloading using non-member function. Okay, so let's do it the way we did it previously. So we say point operator plus, since it is non-member function, so there are two inputs, point A and point B. So what were we doing here? We were doing something like and then you were saying result dot, sorry, not result, a dot get x plus b dot get x. You were adding the x components together and y components together. So we're saying a dot get x plus b dot get x. Why? Because this was outside the class. Okay, int a. Similarly, maybe int b is a dot get y plus b dot get y. And then you were writing, say, result dot set ab and return result. Okay, this is what we were doing with non-member function. Now you see, every time we do this operator overloading with a non-member function, as you had already noticed that we have to call these get functions, right? And then you have to call the set function. Okay, so if you say, okay, why not make it a special function? Special in the sense that why somehow we should grant access only to this function, not to anyone else, so that it can directly access the private data of the class. Okay, and how do we do that? We have some concept of friend function. How do we make a function friend? Okay, all you need to do is you copy the prototype of this function, which is this. Okay, you write it in the class, and with this prototype you use the keyword friend. Okay, so let me just do that so that whatever I have said, you can visually see it and you can see. So I copy the prototype of this function in the class, and before the prototype, you just need to write the keyword friend. Okay, so I write the keyword friend. Okay, and then I write the prototype of this function. Point operator plus first argument is a point. If you want, you can write AB. If you don't want, you don't need to write. It's your choice. Okay. So now this is the key statement. When you do this, you write the prototype of this function in the class with the keyword friend. Now this function has become privileged. Now this function is a friend of this class point. So this function can directly access the private data of this class. So now instead of writing this, you can simply write a.x plus b.x. Similarly, instead of calling these get methods, you can directly write a.y plus b.y. And rather than calling this set function, you can here directly write result.x, result.y. Now you see what is the advantage? Although we are violating the principle of object-oriented programming, right? This is a violation that we say no one other than class should be able to access private data, right? But this is a special case where not every function is granted access. If we want to grant special privileges to some function for some reason, here the reason was that we did not want to call get and set functions every time, right? We wanted that we should be able to write a.x, b.x just like we write inside the class. So for that matter, we introduce the concept of friend function. How do we make friend? We just copy the prototype of the function, paste it in the class, and use the keyword friend. Okay, so this is basically showing you here. And now this function can directly access the private data of the class with dot operator. So you can write a.x, b.x if it's a friend function, right? And please remember, friend is not a member, right? This is not a member function. It is non-member function. It is only a friend. So whether you write it in public or private or anywhere, it does not matter, right? Because I have written it in public, but even if you write it in private, it actually does not matter at all. Why it does not matter? Because it is not a member of the class. When we say public and private, they are applicable only to the members of the class. Since it is not a member, so it will not have any impact, right? So let me show you this example, a clean version maybe from the slide so that you can correlate. Yeah. So you see, this is our point class, which is exactly the same that we have been previously doing. Now the only new thing is that we have added this prototype, okay, in the class function prototype, and we have this keyword friend. Now this particular function we say is a friend of class point. So it means it is allowed to access the private data of class point. Now when we'll make this function, it is a non-member function. This is the reason it is accepting two inputs, right? It is because it is non-member. And but the advantage is that now previously I was calling get x, get y, set x, set y. Now I can just like write one single statement. I can access the x and y coordinate in this function, though it is not a member function, but since it was friend, so that's why I was allowed to do that, right? So if we summarize the findings so far of this complete topic, right? So we say that operator overloading is a concept which allows us to use operators with our own data types. And in this course, by our own data types, we mean objects of our classes, which will actually simplify your program. So first series of examples, we did operator overloading using member function, right? And the key thing to remember was that the number of arguments is one less than the number of operands. Means for unary, there was no argument. For binary, there was one argument, right? And then we saw today operator overloading using non-member function. Sorry, a key difference was that with non-member function, the number of argument is same as the number of operands, means one for unary and two for binary. Okay, but the drawback was that we cannot directly access data. We need to use get and set methods, right? And then at the end, we saw something which is called non-member function, but a special function which is called a friend. The only difference between non-member and friend is that both are non-member, but friend is special in the sense that it can access the private data of the class, right? A few, you can say, friend functions is a detailed topic that we'll see next time, so don't worry about that. Just one important thing is that when you are doing operator overloading, as I told you, you cannot change the number of operand, right? If plus is binary, then it will remain binary. You cannot change the precedence, right? Multiplication is before addition, so it will stay like that. And you cannot invent your own operator, right? Only the existing operators can be overloaded. It is not possible that you say, okay, I will combine this and this and this, and this is my new operator. This is not possible. Only those operators which already exist, you can overload them. You cannot create any new operators, right? This is not allowed, right? So this was basically operator overloading. We conclude this topic. If there are any comments or queries, we can discuss those. Thank you.